Welcome to the Deep Dive, the show where we slice through the information overload to get you truly well-informed, fast. We try to find surprising facts, maybe add just enough humor to keep you hooked. Today, we're literally soaring into a topic that really underpins athletic success across so many sports. Vertical jump height. I mean, think about it. You've got a basketball player fighting for a crucial rebound, right? Or maybe a volleyball player launching for a spike or a block. Even a soccer player needing that burst of explosive power. Your vertical jump is not just some number. It's the direct measure of raw athletic ability. Now, if you've ever looked into jump training, you probably know there's a ton of advice out there, a bewildering amount, really, and often it seems contradictory. So our mission today is to cut through all that noise. We want to bring you concrete scientific findings straight from a comprehensive review of the research. We're diving into a systematic review with meta-analysis titled Effects of Physical Training Programs on Healthy Athletes' Vertical Jump Height. It's a pretty illuminating article authored by Shuzhen Ma, Yanqi Xu, and Simao Xu.
Just published in the Journal of Sports Science and Medicine, volume 24, pages 236 to 257. Online publication was June 1, 2025. And for anyone who want to check it out themselves, the DOI is 10.52082 JSSM.2205.236. So yeah, our mission for this deep dive is clear. Systematically evaluate and compare how effective different physical training programs are for enhancing vertical jump height in healthy athletes. Okay, let's unpack this.
What's truly fascinating here is just how foundational vertical jump capacity is. I mean, across such a diverse range of sports, it's not simply about, how high you can get off the ground. It's a direct reflection of your explosive power. And that power is critical for quick, agile movements in almost any athletic thing you can think of. This ability, it relies heavily on the strength and the lightning-fast coordination of your lower extremity muscles, your leg muscles, basically. It's even used sometimes as a kind of shortcut, a proxy measure, to estimate the proportion of fast-twitch muscle fibers someone has. Those powerful, quick-firing muscles that give you that burst. Just imagine what a top vertical jump means in practice. For a basketball player, it's the difference between, say, effortlessly shooting over a defender or grabbing that crucial rebound in traffic. Huge difference. In volleyball, it's directly tied to pretty much every scoring action, spiking, blocking, even a powerful jump serve. And for soccer players, that explosive power you get from a jump, it's essential for quick changes of direction, winning headers, and it's often a key factor in talent selection too. It's just that important.
Okay, so we get why it's so vital. But how did these researchers actually manage to sift through all the existing studies to give us these clear insights? You mentioned this is a systematic review and meta-analysis. What exactly makes that the gold standard for getting clear answers here?
That's a great question, and it really is key to why this study is so valuable. See, a systematic review and meta-analysis, it isn't just like a random collection of papers. It's a rigorous, very scientific process. They aggregate data from many previous independent studies to draw these broad, incredibly reliable conclusions. Think of it like conducting the same experiment many times in different labs, right? And then meticulously combining all those results to get one super clear answer. The researchers here, they did an exhaustive search across 6 major databases: PubMed, ERIC, Google Scholar, Web of Science, EBScohost, and Scopus. Big ones. That was to make sure they found virtually all the relevant research out there, and they didn't just collect them, they rigorously assessed the quality of each study using something called the Pedro scale. On average, the studies they included showed pretty high quality. They scored an average of 6.23 out of 10, which, it indicates the findings are built on pretty solid ground. For their analysis, they focused specifically on 3 key types of jumps because they're measured slightly differently. There's the standard vertical jump, or VJ, then the squat jump, or SJ, starting from a static squat, and the counter movement jump, CMJ, which involves that dip down first. Understanding these distinctions is important, actually, because different training methods might affect them in slightly different ways.
Right, that level of meticulousness definitely adds confidence to their findings.
Yeah.
Okay, so we know how they gathered the evidence. The big question then is, what did these studies actually compare? Let's peel back the layers on the, 4 main training methods they looked at. Mm-hmm. And these were all compared against a baseline, you said, routine training.
Exactly. And routine training here, you can think of it as just general physical conditioning. So it typically involves activities like jogging, maybe some basic bodyweight exercises, light resistance work. It's crucial for overall fitness and health, definitely. But it doesn't specifically target that kind of explosive power we're talking about for jumping high. It serves as our control group, if you will, the baseline.
Okay, first contender. Plyometric training.
Yeah.
When I hear that, I immediately think of athletes like bounding onto and off boxes. Is that basically it? What's really going on inside the body?
Yeah, plyometric training does involve those explosive movements, but the real magic lies in utilizing what's known as the stretch shortening cycle. Imagine stretching a rubber band as far as it can go, right? Storing up all that potential energy, and then releasing it, letting it snap back with immense force. That's essentially what happens with your muscles. They rapidly stretch. That's the eccentric phase, like when you land from a jump and then immediately contract with maximal effort, the concentric phase, when you jump back up. This really rapid transition allows your muscles to produce more power and act more efficiently. Common examples, like you said, include box jumps, depth jumps where you drop from a height and immediately rebound, and various other jump drills. The primary mechanism here is really about improving your neuromuscular system's responsiveness and coordination.
Neuromuscular, so the brain-muscle connection.
Exactly. That super fast, precise communication between your brain and your muscles, telling them exactly when and how powerfully to contract. It also enhances joint stability. And all that ultimately leads to better jump height and distance. It's about efficiency and speed.
Okay, so plyometrics are all about that spring-like reactivity, making muscles more efficient at using stored elastic energy. Cool. But what about just raw brute strength? That brings us to weight resistance training. On the surface, that sounds pretty straightforward, lift heavy things, but I'm guessing there's more to it than just that, isn't there?
Oh, there absolutely is. While it might seem straightforward, weight resistance training is fundamentally focused on increasing muscle strength and hypertrophy.
Hypertrophy, that's muscle growth, right?
Yeah.
That's it, just muscle growth. You're essentially building bigger, stronger engines for movement. Examples include bilateral exercises, things like squats, deadlifts, leg presses, where you use both legs at the same time. But it also includes unilateral exercises, things like split squats or single-leg deadlifts. These are really critical for improving balance and coordination, especially for movements common in sports. The mechanism is pretty direct. By strengthening key muscles in your lower body, your quads, hamstrings, glutes, you directly enable athletes to produce a more powerful takeoff from the ground. So yes, it's about stimulating muscle growth, but also, crucially, enhancing neural adaptations.
Neural adaptations again.
Like with plyos.
Similar, but different focus. Here, it means your brain gets more efficient at recruiting or activating more of your muscle fibers simultaneously, and sending stronger, faster signals to make them fire with maximum force. More force production.
Okay, strength and better muscle activation. Got it. Now here's where it gets really interesting. You hinted at this. Complex training. This sounds like it's trying to combine the best of both worlds, maybe even more. It truly is, in a way. Complex training involves strategically alternating a specific heavy resistance exercise with a biomechanically similar plyometric exercise. So you might perform a set of heavy squats and then immediately, or maybe after just a very short rest, transition right into a set of depth jumps.
Heavy squats, then depth jumps. Okay, all right.
The brilliance of this method lies in capitalizing on a physiological phenomenon called post-activation potentiation, or PAP. Think of it like this. The heavy resistance exercise, like that heavy squat, it sort of primes your muscles and your nervous system. It temporarily increases your muscle force output. This happens because of heightened neural activation and improved muscle contractility right after that heavy lift. So this priming effect means that when you immediately transition to the explosive plyometric exercise, your muscles are already kind of warmed up at a neurological level. They're ready to produce even more force more efficiently.
Ah, I see. So the heavy lift kind of wakes everything up, makes it ready to fire harder on the jump.
That's a great way to put it. It's a synergistic effect. It often leads to superior results compared to just using standalone training methods. You know, the sum becomes greater than its parts.
Wow, so it's like getting a temporary turbo boost for your muscles right when you need it for the explosive movement. That is really interesting. That explains why combining these different types could be so powerful. All right, we've laid out the contenders. Routine, plyos, weights, in this complex training. Now, for the moment of truth, the scientific showdown, what did the meta-analysis actually find? For each type of jump, which training method truly soared above the rest?
Okay, let's break it down by jump type. We'll start with the classic vertical jump, the VJ. Based on 8 studies they analyzed, both plyometric training and weight resistance exercise significantly improved VJ compared to just routine training. No surprise there, really. Plyometrics led to a solid 5.2 centimeter increase, which is pretty good. But weight resistance exercise showed an even more substantial 9.9 centimeter increase.
Wow, nearly double the improvement for weight training.
Almost, yeah. And what's crucial here is that weight resistance exercise improved VJ by a statistically significant 4.8 centimeters more than plyometric training did. Think about that, nearly 5 extra centimeters. Imagine what that means in a basketball game that could easily be the difference between getting a rebound over someone or not. It's a real competitive edge.
Yeah.
And the SECRA scores back this up. These scores, they basically give us a robust way to rank the effectiveness of each training method against the others. Weight resistance exercise ranked highest, by far, at 0.99212. Then came plyometric training at 0.50709. And routine training was way down at 0.000078. So for the VJ, the order of effectiveness is pretty clear. Weight resistance is better than plyometric, which is much better than routine.
Okay, that's a clear win for raw strength development when it comes to the standard vertical jump. What about the squat jump, the SJ? That's the one starting from a static squat, removing the counter movement, right?
Exactly. For the squat jump, also based on 8 studies, the pattern was somewhat similar, but with a key difference. Both plyometric training and weight resistance exercise significantly improved SJ compared to routine training. Again, expected. Plyometrics increased SJ by 1.5 centimeters, and weight resistance exercise increased it by 3.1 centimeters. So weight resistance still showed a greater average improvement, 1.7 centimeters more than plyometric training. However, this difference was not statistically significant.
Ah, okay. That's interesting. So the average was higher for weights, but statistically you couldn't say for sure it was truly better than plyos for the squat jump. What do you think that is? It feels like we're seeing maybe different paths to potentially similar outcomes there.
That's an astute observation. And yeah, if we connect this to the bigger picture of research, this lack of statistical significance, even with a numerical difference, could be due to several things. For one, the individual studies included in the meta-analysis, they might have had smaller sample sizes for this specific measure. Smaller samples reduce the statistical power you need to detect smaller, but potentially real differences.
Right. Harder to be certain with fewer people.
Exactly. There could also just be more variability in the training protocols across those specific studies, differences in intensity, duration, frequency, that can kind of muddy the waters and obscure clear distinctions. And of course, you always have individual athlete differences. Things like their baseline strength or the previous training experience could really influence how they respond to each method differently. Physiologically, weight resistance focuses on muscle size and neural drive for force, while plyometrics enhance that stretch shortening cycle, muscle elasticity, reactive strength. For a squat jump, which doesn't use that pre-stretch counter movement as much, maybe both pathways converge on similar functional outcomes, making a statistical separation just more challenging. Does that make sense?
Yeah, that makes perfect sense. Different routes leading to sort of similar destinations performance-wise for that specific jump type. Okay, now for the counter movement jump, the CMJ. This one is often considered the most common and maybe the most practical jump assessment because it includes that natural pre-stretch, that dip down. What did the 15 studies reveal here? This feels like the big one.
It is, and this is where complex training truly shines. I mean, it frankly dominates the competition here. For the CMJ, plyometric training, weight resistance exercise, and complex training all significantly improved performance compared to routine training. They all worked. Plyometrics increased CMJ by 2.0 centimeters. Weight resistance exercise by 2.2 centimeters, pretty similar actually, but complex training, it saw a truly significant 5.0 centimeter increase compared to routine training.
5 centimeters. That's a massive difference compared to the other two.
Huge. Complex training was clearly superior here. It outperformed weight resistance by 2.6 centimeters and plyometric training by 2.9 centimeters. Big margins. The SUCRA scores absolutely confirm this. Complex training ranked highest at 0.98365. Then came weight resistance exercise at 0.55400. Then plyometric training slightly lower at 0.46195. And routine training, again, way down at 0.000000. So for the CMJ, the hierarchy is, well, it's indisputable. Complex training is better than weight resistance, which is slightly better than plyometric, and all are much better than routine. It's really fascinating to see how the body responds to that specific combination for this type of jump.
Wow. Okay. So what does this all mean then? For athletes, for coaches looking to truly boost their jumping power, it really sounds like it's not a simple one-size-fits-all answer, but there are definite powerful patterns emerging here.
Exactly. What's really clear is that for the dynamic counter-movement jump, which is so critical in so many sports, complex training is the absolute standout. Its superior effectiveness seems to come from integrating that strength and power development, specifically by leveraging that post-activation potentiation effect we talked about. You're combining the maximal force generation you build with resistance training with the explosive power from plyometrics. You're essentially priming the muscles for more efficient, more powerful contractions. It's a truly synergistic approach. Now, for the purely concentric jumps, the vertical jump and the squat jump, traditional weight resistance training showed really significant benefits. It even outperformed plyometrics for the VJ, as we saw.
And it's not just about the average numbers, right?
Yeah.
The study also mentioned something about low heterogeneity. Can you unpack that a bit? That sounds important for how much we trust these results.
Yeah, absolutely. That low heterogeneity, which was indicated by those I values being really low, between 0.0% and 16.9% for most comparisons, that basically means the results were very consistent across all the individual studies they reviewed. Think of it like conducting the same experiment many times and getting very similar outcomes each time. That consistency really strengthens the reliability of these conclusions. It tells us these findings are highly reliable and probably not just flukes from a few outlier studies.
That's great. That's a lot of confidence.
It does. So for overall jump performance, and especially for that crucial counter movement jump, coaches should absolutely be thinking about prioritizing and incorporating complex training programs. This research provides a really strong evidence-based blueprint for that. That being said, plyometric training alone, it remains highly effective for developing explosive power. And it's particularly useful, maybe, if you don't have access to heavy weightlifting facilities or perhaps in sports like basketball, volleyball, soccer, where rapid force production without heavy external loads is paramount sometimes. And while traditional resistance training does improve jump performance, its effects seem generally more moderate compared to complex or plyometric training, especially for the CMJ. So this implies that for truly well-rounded athletic development, strength development should probably always be combined with speed and power training in some way.
That seems like a really key takeaway. Combine strength with speed and power and do it smartly. So for coaches and athletes listening, it sounds like it's about periodizing your training, structuring programs over time to intentionally combine heavy resistance with plyometrics rather than just doing them in separate blocks or randomly.
Absolutely. It's about designing a smarter, more integrated program that leverages these physiological principles. It's not just about adding more volume for the sake of doing more work. And of course, it's always crucial to consider the individual athlete, their characteristics, the specific demands of their sport, their training history, all that matters. What works best can always be tailored, fine-tuned. But this study provides a really powerful framework to start from.
This all sounds incredibly compelling, but just to be thorough, were there any limitations we should keep in mind about this meta-analysis? I mean, no research is absolutely perfect, right?
That's right. And it's always important to acknowledge them. Like any comprehensive review, there were naturally variations in the design of the individual studies they included, variations in participant characteristics, measurement methods that can sometimes make direct comparisons a bit challenging. Also, many of the original studies had relatively short intervention periods. We're talking maybe 6, 8, 12 weeks. So we can't fully assess the long-term sustainability of these training effects beyond those periods from this data alone. And finally, there's always the potential issue of publication bias. That's the idea that studies showing positive or significant results might be more likely to get published than those with negative or non-significant results. That could potentially skew the overall picture slightly, though the methods used here try to account for that. But even with these limitations, the consistency of the findings across so many studies really makes them incredibly robust, I think.
Okay, so in conclusion then, this deep dive into the effects of physical training programs on healthy athletes' vertical jump height. The article by Ma, Zhu, and Zhu in the Journal of Sports Science and Medicine, it clearly demonstrates that, plyometric training, weight resistance exercises, and especially complex training are all highly effective ways to enhance various aspects of jump performance in healthy athletes. Weight resistance really seems to shine for those pure vertical and squat jumps, mostly by building raw muscle strength and improving that neural drive. But for the dynamic counter-movement jump, which is so critical in so many sports, complex training emerged as the clear winner. It seems to simultaneously enhance strength and explosive power by smartly leveraging that post-activation potentiation effect. The key really seems to be understanding how these different methods enhance muscle strength and explosive power through distinct yet potentially complementary physiological mechanisms. So as you think about optimizing athletic performance, maybe your own or some of your coach, this deep dive hasn't just shown us the most effective ways to boost jump height. It also really underscores a powerful principle. For true performance breakthroughs, maybe we need to move beyond just isolated training methods. Maybe we need to strategically combine them, leveraging our body's complex physiological responses, which makes you wonder, what other athletic skills could we potentially revolutionize by applying this kind of precise, evidence-based, synergistic approach. Something to think about. So those who want to dive even deeper into the specifics, we highly encourage you to read the full article yourself. Again, it's Effects of Physical Training Programs on Healthy Athletes' Vertical Jump Height, a systematic review with meta-analysis. You can find it in the Journal of Sports Science and Medicine, Volume 24, pages 236 to 257. The DOI is 10.52082 JSSM.2025.236. We'll put that in the notes. And please don't forget to follow our channel and turn on notifications so you don't miss our next deep dive into more fascinating topics.